Hello everyone! Today I am going to talk about the carbon footprint of cinnamon buns. Cinnamon buns are a type of sweet pastry, a Swedish delicacy famous for their sugary soft dough and smooth icing on top. They are easy to make, delicious, and are the perfect cozy comfort food during the fall. I am going to discuss what actually goes into making cinnamon buns at home and how they affect the environment. In order to better understand the carbon emission of the process, we first need to identify the ingredients. For the dough, we need some milk, butter, eggs, flour, sugar, and some dry yeast. For the filling and glazing, we need cinnamon, some more sugar, butter, and more eggs. Now, let's look at each ingredient one by one in order to get a more accurate carbon number. Milk and other dairy products have a huge impact on greenhouse gas emissions. Dairy on its own is responsible for 2.9% of human-induced emissions. The largest component comes from the animals themselves because they emit methane during enteric fermentation, which is far more dangerous than carbon dioxide, and it contributes 45% to the total emissions. The feeding and housing of animals contributes far less, and only 5%. However, agricultural inputs such as fertilizers and fossil fuels for feed production also have a large impact. The rest of the emissions come from manure management, post-farm activities, production of other dairy like cheese and butter, as well as packaging and transportation. So, the carbon emission of milk needed for this recipe is 910 grams of carbon dioxide equivalent. Butter is a product of milk, so similarly it has a high carbon emission. Most of it comes from the milk production mentioned previously, which contributes 40% to its overall emissions. For example, one 250-gram pack of butter equates to 1 kilogram of carbon dioxide emission from cows alone. Baking butter is usually packaged in aluminum or paper, so emissions from packaging, transportation, and distribution are much lower at 1 and 6% respectively. So the carbon emission of butter needed for this recipe is 425 grams of carbon dioxide equivalent. Sugar is extracted from sugar beets, and then it is refined in sugar mills and further processed to produce different types of sugar before it is packaged and ready to be transported. The extraction process is the main source of carbon emissions, representing 65%, and the remaining 35% is made up of on-farm emissions and transportation. However, it is important to mention that sugar mills also require huge amounts of electricity for refining sugar. So the carbon emissions of sugar needed for this recipe is 185 grams of carbon dioxide equivalent. Flour production has a lower carbon footprint. However, the agricultural processes and chemicals used for growing wheat are quite harmful to the environment. The largest contributors are the chemicals used for fertilization, representing 40% of the overall emissions. These chemicals also cause a lot of other pollution. In addition, huge amounts of electricity is used during harvesting, irrigation, and wheat mill operation. So, the carbon emission of flour needed for this recipe is 276 grams of carbon dioxide equivalent. The livestock factor has a huge negative effect on the environment, so it's no surprise that the production of eggs also contributes to carbon emissions. Raising chickens contributes 8% to the overall emissions of the livestock factor because chickens emit 0.6 gigatons of carbon dioxide annually. Feed production is the main source of emissions at 69%, while the rest comes from on-farm energy use, representing 4%, post-farm processing and transport at 6%, and manure handling at 20%. So the carbon emission of 2 small eggs needed for this recipe is 530 grams of carbon dioxide equivalent. Yeast production happens through fermentation of sugar byproducts like molasses. The molasses and sugars contribute 23% to the total carbon dioxide emissions, while the actual common process including storage, preparation, fermentation, and cooling accounts for 36% of the total emissions. The process also consumes quite a lot of energy at about 27%, and the rest comes from the aluminum vacuum packaging and transportation. So the total carbon emission of dry yeast needed for this recipe is 30 grams of carbon dioxide equivalent. Cinnamon comes from a specific tree bark that is grown and harvested in India. After the tree bark has been harvested, it is further processed, dried, grated, and grinded to produce cinnamon powder. The actual process of cultivating cinnamon is sustainable, so it doesn't contribute too much to the carbon emissions. However, emissions from the transportation and packaging are quite significant. Marine transport represents 3% of global emissions, and polyethylene packaging used for cinnamon powder is quite high on the list of contributors. So the total carbon emission of cinnamon needed for this recipe is 509 grams of carbon dioxide equivalent. But we can't really stop there. We also need to think about the electricity used by an electric oven to bake the cinnamon buns and how that contributes to the overall emissions. So a standard electric oven at 400 Fahrenheit running for about 30 minutes equates 388 grams of carbon dioxide equivalent per megajoules. Adding all of these numbers together, we get the total amount of 3,253 grams of carbon dioxide equivalent for 10 buns. This means that the total carbon emission of one cinnamon bun would equate 325 grams of carbon dioxide equivalent. This is obviously an estimation, as there are many other factors missing, such as the utensils and baking equipment used, as well as the energy used and carbon emitted while driving to the grocery store to buy all the ingredients. And that's the end of my presentation. Who would have thought that so much goes into baking something as simple as cinnamon buns? I hope next time you make them or buy them, you will remember. Thank you so much for your attention and happy carbon-free baking. Cheers!